Example 5. An exponential function g models a relationship in which the dependent variable is multiplied by 1.5 for every 1 unit the independent variable x increases. Graph g when g of 0 equals 4, and then compare g to the function f of x over the interval x equals 0 to x equals 2. Now, before we get started, there is a typo here. This is a little off, so this should really say f of x equals 4 times 2 to the power of x. Otherwise, that really doesn't make sense. But then we have to compare g of x to f of x. Now, I know it says over the interval x equals 0 to x equals 2, but if we only use that interval, we're not going to get a really good graph. So I'm going to start with g of x. So I'm going to put x, and I'm going to put g of x. And instead of just doing the interval from x equals 0 to x equals 2, I'm actually going to do much more than that. And I'm going to go from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. Now, if I'm strictly talking about g of x here, it's talking about g, and it models a relationship in which the dependent variable is multiplied by 1.5. That's your common ratio. For every 1 unit, the independent variable x increases. So this is our independent variable, and it's increasing by 1. That's what we're doing. And then we're going to take the dependent variable, and we're going to multiply it by 1.5. But the question is, well, where do we start? Yeah, I can multiply by 1.5, but multiply what? So the key here is they give us function notation. G of 0 equals 4, which means when x is 0, this value is 4. And it's telling me, well, take that value and multiply it by 1.5. So I'm going to take 4 times 1.5, and that's going to give me 6. And then I'm going to multiply that by 1.5, which is going to give me 9. And then I'm going to multiply that by 1.5, which is going to give me 13.5. Now, that doesn't tell me the whole story because now I'm missing these. So if I'm going this direction and I'm multiplying by 1.5, how do you think we're going to get that direction? And the answer there is you're going to divide by 1.5. So 4 divided by 1.5 is 2.667. And then divide by 1.5, which is 1.778, and then divide by 1.5, which is 1.185. Now, before I move on, I'm going to take the time and actually put this on the graph. So let's see, -2, 4, so -1, 2, 3. We're kind of like counting half boxes here based on this scale. So -3 and then 1 point, just really small. -2 and just a tad bigger. -1 and then we're at 2.6, which is like maybe right there. 0, 4. So actually, now that I think about that, that one's probably a little high. 1, 6, 2, 9, and then 3, 13.5. So if I'm looking at this and I'm trying to get the view of an exponential function, I'm guessing that it's coming down, not hitting 0. And it's going to do something like this. Now, we are supposed to compare that to f of x. So f of x, I'm going to do the same idea. And what I know about f of x is that they gave me a function. So f of x is really 4 times 2 to the power of x. I'm still going to do it over the same x values. So -3, -2, -1, 0, 1, 2, 3. Again, take a minute, pause your video. We're going to start substituting here. So 4 times 2 to the power of -3 is 0.5. And then to the power of -2 is 1. And then to the power of -1 is 2. And then to the power of 0 is 4. And then to the power of 1 is 8. And then to the power of 2 is 16. And then 32. So if we go put this on our graph, we have -3. And then this guy's at a half, which if we're comparing here is way smaller. So I'm going to try my best. Try your best, but I don't know how you're really going to get that smaller. Here we are a little bit smaller. So again, try your best. And then at -1, we're still a little bit smaller than 2. Well, we're at 2. So still smaller. And then 0, 4, we're at the same point. So we were smaller, really hard to see, but then we kind of hit the same point. So I'm actually going to block that off while I'm thinking about it. Okay, so up until this point, this guy is smaller. And then when I kind of hit this point, we're at the same. Okay, now let's go see what happens. So at 1, I'm at 8, which is bigger. And then at 2, I'm at 16, which is even bigger. And then at 3, I'm at 32, which is way off my graph. So if I go back to this idea here, this is larger. And then we're going to try our best. So we're going to be smaller, which you can barely even fit that in. And then they're going to hit the same point. And then this one's going to get bigger. And both of them still have that horizontal asymptote at 0. But it says to compare. So essentially what we did over here on your table, that's a little easier to compare than it is graphically because it's really hard to see that goes underneath there. But I would say on the interval from x equals 0 to 2, well, at 0, they have the same value. So at 0, same value. And then above 0, 1, 2, 3, or on at 1 and 2, I would say that g of x has smaller values, whereas f of x has larger values.